Welcome to Revista de Ciencias Tecnológicas. This journal belongs to the Facultad de Ciencias de la Ingeniería y Tecnología of the Universidad Autónoma de Baja California.
The study entitled Structural Analysis of Generative Design Applied to Ergonomic Plantar Orthoses was published in the Revista de Ciencias Tecnológicas, RECIT, Volume 9, Issue 2, in 2026. The research was headed by Israel Miguel from CIATEC in collaboration with Christian Nava, Agustín Vidal, Marco Martinez, Luis Ortiz, Juan Garcia, and Sergio Romero. This work was developed through the joint participation of CIATEC and Universidad de Guanajuato, Mexico. This study compares traditional EVA plantar orthoses with generative TPU designs. Structural analysis demonstrates that the generative design optimizes energy absorption and load distribution in the ergonomic insoles. The diagram shows the study's methodology, from baropodometric data collection and material characterization to the final structural analysis via finite elements. EVA material characterization. A40 and A15 specimens and their stress-strain diagram are presented, showing the rigidity of A40 material, which is essential for structural support. TPU A95 is characterized through a tensile test. Its stress-strain diagram shows elastomeric behavior, with high resistance to tension and impact. The modeled bilaminated EVA orthosis, composed of A40 and A15 layers, is shown. This is the traditional geometry used as a reference for the comparative structural analysis. Boundary conditions for generative design. Distributed loads were defined and movement was restricted, including shear forces in the key support areas. The result of the generative design is an optimized TPU orthosis. Internal trabecular structures are observed, focused on guaranteeing the required structural support and stiffness. Boundary conditions for static numerical simulation were defined. Only compressive forces on the z-axis were considered to simulate static standing load. Elastic deformation is compared. The generative design shows a homogeneous distribution in its trabecular structures, operating within the elastic regime of TPU. Total deformation. The EVA orthosis is rigid with limited displacement. The generative design is more deformable and efficiently distributes the load through the geometry. Strain energy. The generative orthositis absorbs 10 times more energy, 0.3876 joules, than the EVA one, confirming a high load dissipation capacity. As a conclusion, the generative design optimizes the mechanical response of the orthoses, but these results are preliminary and based on simulation. Experimental validation is required to confirm their clinical applicability.
Muchas gracias por tu colaboración en la Revista de Ciencias Tecnológicas RECIT. Publica con nosotros. Publica RECIT.